Welcome to section 10.3. We're going to be talking about probability, and this is the one that probably is the most familiar to you as you go through. But let's actually start. This is, again, we'll walk directly with your frame. And so let's talk about what we're doing. First things we're doing is we're going to be working with finding a probability of an event and giving it a value. And the biggest thing about your value, this value is going to be between 0 and 1. And what that basically says is how likely is the event going to occur. If the probability of an event, I'm going to write out notation, is 0, then it's not likely to occur. Okay, or happen if you want to use that word. If the probability of the event is 1, then it will occur. Okay, so the closer it is to 1, the more prominent it is to occur. The closer it is to 0, the less likely it will occur. And so that's kind of the idea. We want to talk about a couple of things: theoretical probability and experimental probability. And so we're going to talk about that kind of as we go through. Now take a look. We're going to start with theoretical probability. Theoretical probability is basically what we expect to happen. So what we expect to happen when we say it in a perfect world. Okay, according to the numbers, this is what should happen. Now that's not always the case, but this is kind of overall generally what we expect. The idea of probability is how many things occur in A divided by how many possible outcomes there are. And so we've tried to give you an idea, like how many, if I give you an idea, how many females are there in the whole world? There's a probability that the person you pick will be female out of the whole population. That's kind of the idea going through. So let's take a look. Here is a deck of cards. Now, if you are not familiar with a deck of cards, please try and get a deck soon because you need to know what's in there. And if you look, basically there are 4 suits, and you have clubs and hearts and what we call spades and then diamonds. Okay? Each suit, those are called suits, each suit has 13 cards in them. An ace, 2, 3, all the way up to jack, queen, and king. Jack, queen, and king are what we consider face cards because they actually have a face on the front. And so this is kind of what we're going to be working with along the way. So if I give you 52 cards in this deck, what's the probability that you get a red queen? And so when I do this probability of a red queen, and I'm going to write way more out than you may need to, I want the number of red queens divided by the number of cards in the deck. Okay, and I'm writing this out. If you don't need this step, that's fine. I'm just trying to write it out for you. Well, if I look at my deck, there are 2 red queens. I have a red queen in diamonds and a red queen in heart. So there are 2 red queens out of the 52 cards in the deck. You always want to reduce. Okay, so make a little note. Always reduce. And as I look at this, 2 over 52 reduces to 1 out of 26. I want your answers for probability as fractions. The only time you should give me an answer in a decimal is if they start you with a decimal. But this is the first idea. Again, keep in mind what a deck of cards looks like. So the next type of probability that we have is experimental probability, and that actually is the probability. So what actually happens in an experiment? Okay, so experimental probability means you're using data from an experiment. And they're going to give you some data, and it's the number of times again divided by the number of trials you actually do. And so this should be pretty easy to kind of follow as we go through. So here's an example. Their exam grades of students in a history class are shown below. Find the probability that a student chosen receives a C or better. That means they got either a C, a B, or an A. And so if I want the probability of a C or better, I'm going to write this out for you. It's students that got a C, a B, or an A divided by the total number of students. So let's take a look. How many people got a C? We're looking at 8 plus 12 is 20, plus 7 is 27. Over our total, and I'm just going to make a side note here, our total number of students, 3 plus 1 plus 8 plus 12 plus 7. So this is 27, 28, 31. So it's divided by 31. Again, if you can reduce, you should reduce. In this case, you can't. So our experimental probability is 27 over 31. And this is the type of thing that we're going to give you. We're going to give you some sort of data and ask you to use the data as we go through. That's the first idea. We looked at both theoretical and experimental probability. So the back side, we're looking at what we call odds. The idea of odds is really nice, but I find that you can make a lot of little mistakes. So I'm going to walk through this pretty thoroughly. You have basically odds against and odds for. And it's always written like this with colons. So we're not going to write it as a fraction, even though your book says you can. And I'm trying to do that to separate any mistakes we'll make. So take a look. Odds in favor, here's what it means. It means that you're looking for the number of outcomes in A to the number of outcomes not in A. And so the way I look at it is yes to the A, and then colon, no to the A. And I'm trying to spell this out as we kind of go through. But again, the idea is pretty simple. It's easy mistakes though. Okay? The odds against goes like this, the number not in A to the number in A. So I say no to A, and then yes to A. And the biggest thing with odds add up to the total. So kind of keep that in mind. Odds add up to the total. Okay? So take a look. All right, here's an example for you. We give you a bag that has 6 marbles, 12 yellows, and 6 red marbles, 12 yellow marbles, and 9 black marbles. We want the odds in favor of drawing a red. So here's the way I personally start off. If you want it in favor, that means I start with red, and I do it to not red. Okay, and that's the way I'm working, is how many are red to how many are not red. Well, there are 6 of them that are red, and 12 and 9 are not red, so 12 plus 9 is 21. Now, odds should be reduced, okay, just like you did probability, but we keep them in the colon form. So I can take a 3 out of each of these, so I can reduce this 2 to 7. This is the odds in favor of getting a red. So always reduce them. Second one, find the odds against drawing a black. That means not black, because it's against, to how many are black. Well, if I look at my number of marbles, I have 6 that are not black and 12 that are not black. So 18 of them are not black to the 9 that are black. This again can be reduced. I can take 9 out of each of them, so 2 to 1. Now, take a look before I finish this. These two, 18 plus 9 equals 27, and if I add these 3 together, I get 27 marbles as well. And so what we want you to know is that the number of odds together will equal the total number of marbles or chips or whatever it is we're working with. And so this is the idea for section 10.3. We're looking at basic types of probability, and then we're talking about odds. Again, odds is the one that we tend to make the most mistakes with, so just kind of be careful as you go through. And that's why I always write these statements before I answer anything, so that I know, have I set them up correctly. Okay. Again, don't forget, when you're dealing with odds, the 2 numbers always add up to the total. And keep that in mind. Again, that's what's different about odds. That's it for section 10.3. Thanks for watching.